Hi everyone, I'm Christian Babayanon and let's talk about the aliphatic, alicyclic, and aromatic hydrocarbons. Okay, in organic chemistry, hydrocarbons are divided into two classes. We have aromatic compounds and aliphatic compounds, also known as non-aromatic hydrocarbons. Aliphatics can be cyclic. However, hydrocarbons with conjugated phase systems that obey Huckel's rule are instead considered to be aromatic. So what is the difference between aromatic and aliphatic hydrocarbons? Aliphatic compounds are composed of straight, chain, branch, or cyclic compounds and can be saturated alkanes or unsaturated alkenes, alkynes, and others. Whereas aromatic compounds have one or more conjugated benzene or heterocyclic rings within their structure. Occasionally, we find aliphatic hydrocarbons with the ring of C atoms. These hydrocarbons are called cycloalkanes. Yes, cycloalkanes. Cycloalkenes or cycloalkynes because alkanes have the maximum number of H atoms possible according to the rules of covalent bands. Alkenes are also referred to as saturated hydrocarbons. So what are alicyclic hydrocarbons? It is an organic compound that contains one or more closed rings of carbon atoms. The term alicyclic specifically excludes carbocyclic compounds with an array of an electron characteristic of aromatic rings. Okay. So here are the types of hydrocarbons. Hydrocarbons is an organic compound made of nothing more than the carbons and hydrogens. It is possible for double or triple bonds to form between carbon atoms and even for structures, such as rings to form. The classifications for hydrocarbons defined by UPAC nomenclature of organic chemistry are: we have aliphatic, we have alkane for single bond, double bond for alkene, and triple bond for alkyne, and we have aromatic hydrocarbons. Okay. Hi everyone, I'm Christian, and these two tables are extremely important you to know, or important us to know. Okay, we have case 1, case 2, case 3, case 4, and case 5. Since we're naming alkanes, we go over for the different 5 cases. We have case 1, case 2, case 3, case 4, and case 5. Okay. This table, the first table, show the prefixes for the different names of carbon chains you may see. Since we are naming alkanes, every structure name will end at ane. So we have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and 10 for decane. The second table shows the common substituents you will need to know. For naming alkanes, you will follow these 3 main steps. For the step 1, find the longest carbon chain, and step 2, number the carbon chain, so we have the most substituents and lowest number at each substituent. And lastly, step 3, identify the type of substituent. Okay, case 1. Let's apply the case 1. One substituent for one substituent. This is how we will format the name of the structure, with the number is location of the substituent followed by a dash, the name of the substituent, and the name of the longest carbon chain. So there are no spaces and nothing is ever capitalized. Okay, step 1. Find the longest carbon chain. So there is 1, 2, 3, 4. four carbons to this way. Or 1, 2, 3, 4 to this way. So the longest carbon chain is 4. So the prefix for 4 is but, and it ends in A. For alkane, so we have butane. Yeah, butane. Step 2. Number the carbon chain, so we have the most substituent and lowest number at each substituent. Okay. So if we number the carbon chain from left to right, the substituent would be at 2. If we number that from right to left, the substituent, would be at 3. Yeah. So we'll keep it number from left to right since we always want the lowest number for 4 substituent. We know the locations of our substituent is at 2. Step 3. Identify the type of substituent. There is only one carbon and it's not already part of the main carbon chain. So this is methyl group. And we get two methyl butane. And we could number this differently by starting off this end. We have 1, 2, 3, and 4, and it would give us the same exact answer since the methyl group is still at 2. Okay. Case 2. The structure has 2 of the same substituent. Here how will form at the name whenever structure has 2 or more same substituent. We separate the number first with a comma, then there's a dash, a prefix goes to in front of the name, and the substituent followed by the longest carbon chain. So step 1, find the longest carbon chain. We have 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5 to this way. Okay. We know that 5 is the longest carbon chain, so the prefix for 5 is pen. So we write pentane. Step 2. Number the carbon chain so we have the most substituents and lowest number at each substituents. Okay. Here's in a different ways we could have numbered this structure. This first one shows the substituent at 2 and 3. The second one shows the substituents at 3 and 4. And this third one also is that 3 and 4. So the correct numbering is the first one, since we get the lowest possible number for substituent. So 2, 3 goes in front. So step 3, identify the type of substituents. So we have 2 metal groups, and since there are 2 the same substituents, the prefix for 2 is di because we have 2 metal here, so dimetal. And this is the structure name, the name of the structure, so dimethyl. Yeah, 2, 3, dimethyl pentane. Next, we have the case 3. So the structure has different substituents. Here's how we'll format the name with the 2 different substituents name and the number there located followed by the longest carbon chain. So step 1 again, find the longest carbon chain. So we have 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, since the longest carbon chain has 7, so 7 carbon, so we choose heptane. Next, we have step 2, number the carbon chain, so we have the most substituents and lowest number at each substituents. So here are some possible ways, numbers, all the ways gives the same amount of substituents, but only ways 1 and 2 have the lowest number at substituent. Way 1, 2 the same answer, so I pick 1. So step 3, identify the types of substituents. So we have a metal and ethyl group. Always write substituents in alphabetical order. So the ethyl goes first, then the metal, and we're placing numbers where each substituent is at an, so this is the correct name. So we have 3 at ethyl and 4 methyl. So this is the name of the structure. We have 3 ethyl, 4 methyl heptane. Case 4. So the structure has 2 different long carbon chains. Some structures have 2 completely different size carbon chains, which we'll see here. So step 1, find the longest carbon chain. So let's see what we have. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 5, 6, 7. Okay. So 7 is the longest carbon chain, which is heptane. So step 2. Number the carbon chain, so we have the most substituents and lowest number at each substituents. So here are 2 ways we could number the chains. So this first way is the best since substituents are at 3 and 4 rather than 4 and 5 because we always want the lowest numbers for each substituents. So step 3, identify the types of substituents. We have a metal group at 3 and we have an ethyl group at 4, and we always arrange our substituents in alphabetical order. When we do that, we can have this: 4 ethyl and 3 methyl heptane. 4 ethyl, 3 methyl heptane in case 4. Next, we have case 5. So the structure has multiple same length carbon chains. So in this step 1, find the longest carbon chain. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbons are here. So 9 carbons is 9A. So step 2, number the carbon chain. So we have the most substituents and lowest number at each substituent. So here are different ways to number the carbon chain. Remember, we want the way that gives us the most substituents. Way 1 gives you